Hi, here giving you another video on direction. This is a direction angles for vectors. We are in chapter 8.3, finding direction angles. Let's look at how we do that. The direction angle can be found using some basic trig properties. Okay. For the direction, we will use the angle theta to be a result of using sine, cosine, and finally tangent of theta. So we're going to use some basic trig functions to find our direction angle. If we look at this example, or kind of a drawing here first, we can find we have the xy axis. U in purple is going to be the vector that we're trying to find an angle for, angle theta here in red. Now, u, the vector, is made up of components. Component u sub 1 in the x direction, and then u sub 2, which is in the y direction. So now we can put some right triangle trig functions to work here to help us find what this angle theta is based on our u. Now remember, u can move anywhere around, but we put it in standard position here to begin with, and then we can move u, and it'll always have the same direction angle. So if we look at this situation, let's move it a little bit. Here we have cosine, if you recall, is equal to the adjacent side over the hypotenuse. We have sine is equal to opposite over hypotenuse. And we have tangent, which is opposite over adjacent. Okay, so here we have that. Now, if we put this in terms of u, we get u sub 1, or this x, in the x direction, will be equal to the u, the vector u, times cosine. Now, the reason why that is because we take this hypotenuse. Well, what's the hypotenuse? The hypotenuse is u, right? The vector. So now we have u sub 1, or the component of u, is the result of the vector u times the cosine. For our sine, we're going to use u sub 2, right? If we, again, take the hypotenuse, which is u, in our right triangle, and we remultiply that by the other side, we'll get u times the sine of theta is equal to u2. All right, now, we bring in tangent, and we find that tangent is opposite over adjacent. And so we get u sub 2 over u sub 1, right? That's opposite over adjacent, which is also equal to u times the sine of theta, just substituting blue and green, just like we did here. And so we get u times the sine of theta over u times the cosine of theta, which then ultimately these u's will cancel out, right? Those u's can cancel. And then the tangent of theta is just left with sine over cosine. Well, what is the sine? If we said that the sine was, if those cancel, then it's just u sub 2 over u sub 1. So the sine over the cosine. So what are the components of u sub 2, or the y component, or over the x component? If we know these x and y components based upon our function of u, then we can then take the tangent inverse of the y component or the x component, and we will get our angle theta. All right, so let's look at an example of that. It says, find the direction angle for the vector w, which has components of 3, -4. So I've drawn it for you here. We have the vector w. Okay, I guess I should have labeled that, vector w. Okay, there's our vector w. And it has components of 3 in the x direction and -4 in the y direction. So I want to find theta. So quite simply, I know that was a long proof of how we got there before, but now we can find theta as the tangent inverse of the y component, or -4, right? -4 in the y, over, or divided by, the x component of 3. When you plug that in your calculator, you will notice that you get an angle of -53 degrees. And if you recall for trig, this could be 0 as well as 360, but if we go the opposite direction or clockwise, we will get a negative angle. Okay? And we could find a coterminal angle for this, or a positive angle, if we started the other way and came around this way. But largely, it's quadrant 4, so we could call this a negative 53 degrees. All right? Hope you enjoyed. Thanks a lot. That is finding the direction angle for your vector.